Here we go. So 8.4, cube and cube root equations. Guess what, guys? How you solve cube and cube root equations is exactly the same how you solve all other equations.
No.
Mind blown, I know. So what do? You use inverse operations. I know, crazy that we're still being surprised at the end of the year. But yes, you use inverse operations. So what's the opposite of adding? Subtracting. What's the opposite of multiplying? Dividing. Okay. You want to check your work at the end if you don't feel confident by plugging back in for X. Bam, big surprise. Here we go. So we're going to do the first example together. Then I'm going to have you do the second example with your group. Cool. All right. So we have the cube root of 5x minus 1 equals 4. And it wants us to solve this. So what's the opposite of cube root? To cube it. So in order to cancel out the cube root, what do I need to do? Cube. And what I do to one side, I have to do to the other. So this cancels out my radical, and I'm left with 5x minus 1 equals 4 to the third. 4 to the third means that I have 4 times 4 times 4, which equals 64. So we have, is it okay if I just write 64 right here? All right, now we need to get x by itself. So what do we need to do? What's the first thing we need to do to get x by itself? Add the 1, because you can't just go straight to the x. You got to work your way there. So we have 5x equals what's 64 plus 1? 65. What's the last thing we need to do to get x by itself? Divide by 5. Oh my gosh. And what's 65 divided by 5? It is 13. Yay. We did it.
Boom.
How do we feel?
I feel good.
Feel good? Totally doable, right? All right, here we go. Here is yours. Go for it. All right, let's see how we did. All right, so just because the 5 is here, if it bothered you, all you have to do is move it to the other side, right?
Yep. No,
And then the process begins the same. What did you do?
wait, I didn't move mine.
You didn't have to. You cube both sides, and we're left with 7x plus 6 equals, what's 5 times 5 times 5?
125.
125. And then you should have subtracted your 6,
119.
and you get 7x equals 119. Then you divide it by 7.
And it's 17.
7 goes into 11 one time with the remainder of 4. 7 goes into 49 7 times. And your answer is 17. How do we feel? Doable?
Amazing.
I mean, I guess.
All right, we got to do our traditional real world example. Here we go. Earth science. Okay, for meteor crater in Arizona, the formula D equals 2 cube root of V divided by 3/10 relates the diameter D of the rim in meters to the volume V in cubic meters. What is the volume of the meteor crater? All values are approximate. Okay, well, notice here how our diameter right here that's given to us, it's in kilometers. But what are the values in the formula? Meters, right? The values in the formula are in meters. So before we can do anything, what will we need to do? Convert, right? All right, so I don't know what your teachers did, but my 5th grade science teacher, this is how I was taught to convert with customaries. And it's kangaroos hop down mountains drinking chocolate milk. Okay, that's how I learned it. So this is your kilo, your hecto, your deca, your meters, your deci, your centi, and your milli. Okay, so this is your customary units, right? So your teachers, I don't know what y'all learned or how y'all learn how to convert between customary units, but I learned it as kangaroos hop down mountains drinking chocolate milk. Okay. When you hop down, you multiply. When you hop up, you divide. That's literally how I learned it. And that's because our customary units is based off of powers of 10, right? 10 to the first, 10 to the third. I don't know. Yes. Oh, what are you learning in science?
I didn't learn anything in
Physics.
science.
So if I have 1.2 kilometers and I need to get to meters, I'm going to hop down 1, 2, 3. I hop down 3, which means that I'm going to multiply. Down is multiply, up is divide.
Yeah.
I went down, so I'm going to multiply, which just means that I'm moving my decimal place to the right. So down is multiplying, up is dividing. So I'm just moving my decimal places. How many places to the right? 3, because it's 10 to the third, which is 1,000. So you're doing 1.2 times 1,000, which just means I'm going 1, 2, 3, which makes this 1,200 meters. So that's converting in customary units. All right. So now that I have what D is in customary, so I know that this is 1,200 meters. Now can I plug it in and solve the equation? Yes. So we have 1,200 equals 2 to the cube root of V divided by 3/10. And now I just got to get V by itself. Okay, so on the outside, I have 2 being multiplied. The opposite of 2 being multiplied is for 2 to be divided. What is 1,200 divided by 2? 600. So we have 600 equals the cube root of V divided by 3/10. What's the opposite of cube root? Cube. Now I'm going to keep it as this until the very end. So we have 600 cubed equals V divided by 0.3. And then what's left for me to do? Times 0.3, multiply. And what I do to one side, I do to the other. So in the calculator, I'm putting in 600 to the third times 3/10. And that's going to give me my volume. So let me pull up my handy dandy calculator. So I'm doing 600 to the third, and I get 216 million times 3/10, and I get 64,800,000. So that's the 64,800,000 cubic meters is the volume. So I'm gonna write 64,800,000 cubic meters.
Hey. That was like a little Dwayne Wade, LeBron James moment.
Okay,
Little alley-oop.
You can
Mine.
move
All
in
right.
your room. I will help you move.
thanks.
Sam.
All right, question next. So we're gonna be here solving equations with rational exponents, okay? So it's gonna get a little different here, and there's a couple ways of solving this. But the main thing you wanna remember that a rational exponent means that you have an exponent that is a fraction, okay? That's what a rational exponent means, okay? Second, you wanna isolate the term or factor with the rational exponent using inverse operation. So you wanna get it by itself, okay? And then you want to raise the side of the equation to the reciprocal of the exponent. And what does reciprocal mean? Anyone, what does it mean to, what's the reciprocal of a number? You flip it. It's when you flip it. So if I have 2/3, its reciprocal is 3/2, right? 2/3 reciprocal is 3/2, okay? Then you're gonna raise the side of the equation to the reciprocal exponent, and you simplify both sides. Now, one thing we gotta remember is that when you have an exponent, so if I have x to the 2/3, what this means is that you are taking the cube root of x and squaring it. Does that make sense? Do you remember that? You're taking the cube root and squaring it. There's two parts. So if there's a fractional exponent, that means there's two things that's taking place, okay? I have a power and I have a root, okay? You remember that? Yes, ringing a little bit of bells, for exponents, okay? All right, let's dive in. So here we have 3 times x plus 1 to the 2/3 equals 12. So step one is you want to get your factor that has the exponent by itself. So what needs to move so that x plus 1 to the 2/3 is by itself? 3. How do I move the 3? Divide it. Perfect. So I divide both sides by 3, and I'm left with x plus 1 to the 2/3 equals 4. Okay. The next thing it said first to do is to find the reciprocal of the exponent. So the reciprocal of 2/3 is 3/2. I see where he was going. Okay. 3/2. And what I do to one side, I do to the other. This is going to cancel this side out. And I'm left with x plus 1 equals 4 to the 3/2. So what this is telling me is that I am taking the square root of 4 and I am cubing it. Does that make sense? So we're taking the square root of 4 and we're cubing it. Or we're cubing 4 and taking the square root. Does it matter which way you go? No, it does not. So which way do we want to go? We want to square root, then cube it. All right.
No, that's cube and the square root.
Not bro. Same thing, bro.
Either way. So we'll do both just for fancies. Here's our last notes, you know. Let's go out with a bang.
Who made the math right? You know what I'm saying?
Somebody.
Like who made math like?
All right. So if we did it where we did 4 cubed and then took the square root, what is 4 cubed? What's 4 times 4 times 4? 64. And then the square root of 64 is positive and negative 8, right? So you could have done it this way or the other way. So the other way is you're going to square root 4 and then cube it. What is the square root of 4? Positive negative 2, right? And then when you cube positive or negative 2, what does it become? Positive negative 8. Does it matter which way you do it? No, the end results are the same. Okay, so we have x plus 1 equals plus or minus 8. What does the plus or minus mean? It's either going to be a positive or a negative. We have that both happening, right? Because we took an even root. All right, what's the last thing I need to do? Subtract the 1, right?
Yes.
So we have x equals -1 plus or minus 8. And we talked about this during our square root unit. That means you have two answers, right? One when you add 8 and one when you subtract 8. What's -1 plus 8? 7. What's -1 minus 8? -9. So our two answers are
7 and -9.
7 and -9.
One over 2 times.
No, I think I do question. No.
Okay, now why do we have two answers? The reason why we have two answers again is remember that we had an even root. Okay, that's the only reason why, is because we had an even root. If we had an odd root, will we have two answers? No. Okay. All right, we're gonna look at odd roots. Ready? So example 5. Yes. So example 5 is already written as a radical. Example 5 can also be written as 3 parentheses x plus 1 to the 5/3. So it could have been left as a rational exponent, but we went ahead and wrote it as a radical and an exponent instead of keeping it as a rational exponent. Okay, these are equal problems. Does that make sense? They are the same problem. I forgot the plus 1. Just written in a different form. Okay, so your other option is to go ahead and in the beginning, take your rational exponent and write it as a radical and exponent separate, and then go from there. Okay. All right, here we go. So the job is to get this by itself. So what needs to move first? The 1. So we have to subtract 1 from both sides. So we're left with 3 cube root of x plus 1 to the 5th equals 96. Now what needs to go? The 3. So I'm going to divide both sides by 3. And we're left with the cube root of x plus 1 to the 5th equals 32. Now what do I need to get rid of? The 3, the root. How do I get rid of that? No, you put a power to it. So it's 3 to the power, to the 3rd power. So it's gonna, and we're left with x plus 1 to the 5th power equals 32 to the 3rd power. How do I get rid of an exponent?
This, the thingy, what's it called?
The root.
Yeah.
Finding the root of it, right? So the opposite of to the 5th power is to find the 5th root. Okay. Instead of me having to write it as a 5th root, it's okay if I just write it as 3/5? I can, because the denominator of the exponent is my root. The denominator of my exponent is the root. All right, so what number times itself 5 times makes 32? What number times itself 5 times makes 32?
4, 6, 6, 5, not 5.
2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16 times 2, 32. So the 5th root of 32 is 2. What number times itself 5 times makes, all right. All right, what's left to get x by itself? -1. All right. So what does x equal? What's 2 to the third minus 1?
X equals 1/3.
What's 2 to the third? 2 to the third means 2 times 2 times 2. What is that? 8. What's 8 minus 1?
7.
So my answer is 7.
Yeah, watch the bank.
So on this one, I'm going to show you, if you don't want to work it as a fraction, you can also write it as a root. So as a root, this would be 2, and your denominator is your radical. So it's 2 cube root of x plus 3 squared equals 8. Whichever way you feel comfortable solving it is up to you. Okay, they're both the same. It's going to end in the same. Okay, so not right now. So first thing is to get our rational exponent factor by itself. But what do I need to do to get this by itself? Divide. So we're left with x plus 3 to the 2/3 equals 4. Okay, to get rid of the rational exponent, you multiply by its reciprocal. What is the reciprocal of 2/3? 3/2. So I multiply by 3/2. What I do to one side, I do to the other. Cancels it out. So we're left with x plus 3 equals the square root of 4 to the 3rd. Does that make sense? My denominator is my root. My numerator is my power. We see that? Okay, what is the square root? What is 4 to the 3rd? 64. What is the square root of 64? Plus or minus 8. Because when you take the square root of something, it produces a positive and a negative. What's the last thing I need to do to get x by itself? Subtract 3. So x equals -3 plus or minus 8. What does the plus or minus mean? You have to add and subtract. So what is -3 plus 8? 5. What is -3 minus 8? A -11. So your two answers are 5 and -11.
Oh my God.
Nope.
Oh.
All right. It's not in your notes, but just to go over with you, if all else fails and you have a graphing calculator, you can just purely use, especially when there's larger numbers, you can use your graphing calculator to solve. So if you remember these steps, they're right here. 1, you graph the left side of the equation. 2, you graph the right side of the equation. And then 3, you're looking for the what? The intersection. You're looking for the intersection of the two. Okay, the x coordinate is the solution. Sometimes you might have more than one intersection, so make sure you write them both down. All right, that is the last and final thing I have to tell you for algebra dose.
167. It's in order.
There you
So
go.
whenever you go in my notebook, you just have to